Hey guys, alright, so welcome back to part 2 of our end of term exam for the period of September to December 2021. In the last video we did questions 1 and 2. This paper is constructed by me, and again, this is just to facilitate a few of my students that I have been teaching for the latter or the first term of the 2021 or the year 2021. So again, this may be of benefit to you wherever you are, but this paper is geared towards giving my students the solution to this paper. All right. Again, follow me on the Instagram at Apex Academy of Mathematics. Follow me on Facebook at Akin Math Paired Wiz. And also check in the description box below if it is that you see any links towards previous videos that may be of assistance to you, as well as information in my WhatsApp contact if it is that you need any assistance with math directly. All right, so thank you, and let's just get right into part 2. We're at question 3 in the algebra section. Alright, now here we are asked to simplify the expression 3x squared minus 4xy plus y plus 2x squared plus 7y minus 5 plus 9xy. Okay, definitely going to need some space for this. Just going to move this down a little bit here. Alright, and let's get into it. So first thing, we are going to need to arrange according to terms that are alike, or arranged like terms, or group like terms, as most teachers would say. So we're going to start off here by saying start off with the square, so 3x squared. Let's move this 2x squared right beside here. There are no more squares, so we're going to move on to the xy terms. So that's minus 4xy. There is a plus 9xy over there, so here and here. Then we're gonna have the y terms, so that's plus y, and that's plus 7y, and then we have that last constant here, minus 5. So grouping like terms, so 3 plus 2 gives us 5x squared. Remember, when we're adding and we're subtracting, we do not manipulate the powers. We just simply add or subtract the coefficients, and we rewrite the base, which in this case the base is x squared. Alright, so we have negative 4 here plus 9. Be careful, this is negative 4 and not 4. So negative 4, positive 9. 9 is bigger, so we take the 4 from the 9. We are left with 5, so that's plus 5. And because the sign of the 9 is bigger, then it becomes positive 5xy. Then we have y, which is 1y plus 7y. That's equal to 8y, and that's minus 5. So we have no more terms that are alike. So our simplified version for this answer is 5x squared plus 5xy plus 8y minus 5. All terms here are unlike, so we cannot go any further. That brings us to the end of part 1 of question 3a. Okay, good. So hope you guys got that. Let's erase here. I'm a little bit sick today, guys, but that's fine. Let's just move this down here a little bit, and let's just move this up here. Get some space here. So now what we have here, we're just going to be doing some distribution. There's a couple of ways in which that we could do part A here, and I'm going to do it both ways for you. So we have minus 3, open bracket, 7x minus 2, open bracket again, 4x plus 1. So here's method 1. We could distribute the 3 here, and we're going to end up with another binomial expression. So minus 3 times 7x gives us minus 21x. Minus 3 times minus 2 gives us positive 6. We're going to have to put that back in a bracket, and then multiply it by 4x plus 1. Alright, so we're going to do what is known as the distribution law we're going to take the first term, which is negative 21x here, and we're going to multiply it with the bracket over there, which is 4x plus 1. We're going to take the positive 6 here, which is the second term, and we're going to multiply it by the second bracket again, which is 4x plus 1. So we do the same distribution process that we did at the start of this question. So 21 will multiply the 4x, and 21, negative 21 will multiply the 1. 6 will multiply the 4x, and the 6 will multiply the 1 here. So we're going to end up with negative 21 x times 4. The 21 times the 4 gives us negative 84. X times x is x squared. Negative times positive gives us a negative. 21x times 1 is equal to 21x. 6 times 4 is 24 with the x, so that's 24x. And 6 times 1 is 6. Okay? Alright, and now the terms are in the center here, so we end up with negative 84x squared. There's no more terms to group that, so that's negative 84x squared. And negative 21 plus 24, that's positive 3x. And that's going to be plus 6. Okay, that's going to be our final answer. So what we did in this method is that we used 3 to distribute into the first binomial bracket. Then we did the product of two binomial expressions by using the first term from the first bracket to multiply the two terms in the second bracket, grouping like terms, and simplifying. There's also another method in which we could do this, and I'm going to show you this, obviously, because different students learn in different ways and everybody sees the problem a different way. So method 2 could obviously be, let me see here, minus 3 open bracket 7x minus 2 open bracket 4x plus 1. So we could do the binomial expression first. We could write this minus 3 here, and we're going to open a square bracket, and then we're going to distribute here. Okay, so what we're basically doing here, all right, we are leaving the minus 3 for last, so that's minus 3. Open a square bracket, then we're going to use the 7x to multiply the bracket over here, which is 4x plus 1. Then we're going to be using the minus 2 to multiply the bracket over here again, which is 4x plus 1. Okay, all right, so we have the minus 3 for last. Open our square bracket here. 7x times 4, that's 28x squared. Okay, 7 times 1, that's positive 7x. Minus 2 times 4, that's minus 8x. And minus times positive is minus. 2 times 1 is 2. And then finally now, we're just going to be using the minus 3 to distribute inside the bracket here. So that's minus 3 times 28, that's negative 84x squared. We could simplify these two here. So if we simplify 7x minus 8x, we're going to get negative x. But then if we use the minus 3 times the negative x, we're going to get negative 3x. Okay, so I actually should have simplified this in the next line. So 7 minus 8x is negative x. That's why I have it up here. And then the minus 3 times the negative x gives us positive 3x. And then negative 3 times negative 2 gives us positive 6. So we end up with the same result as over here. Okay? Those two methods can work. It just depends on what you prefer to do first. My personal preference, I always like to do the product of two binomial expressions first, then I do the final distribution. That's just kind of my preferred method, but it completely depends on how you feel as a student. Okay? Alright, so now that that question is over, definitely you can just rewind the video to follow with me as I go along. I recommend that you try the questions first and then you see the solutions. Okay? Alright, so let's move on now. Let's get some space here. Let's let's move on to the next part. So now we have another product of two binomial expressions here, and then we have a simpler distribution over here. So once again, we're going to use the 4x here to multiply the bracket over here. 3x plus 1. We're going to use the plus 5 to multiply the bracket over here. 3x plus 1. And then we're going to use the minus 3 again to distribute with the x plus 1. Okay, so we have a series of basic distributions here. The 4x multiplies here and here. The 5 multiplies here and here. And the minus 3 multiplies here and here. So 4x times 3x, that's 12x squared. 4 times 1 is 4, along with the x, so that's 4x. 5 times 3x, that's 15x. 5 times 1, that's positive 5. Minus 3 times x is minus 3x. Minus 3 times 1 is minus 3. Okay, and we just group like terms. You can write another line if you want to, just grouping all the x's together, but it's kind of not that difficult. There's no more x squares to group with the 12x squares, so that remains. The 4x with the 15x gives us 19x, so these two here gives us 19x. And 19 minus 3 gives us 16x. And then 5 minus 3 gives us 2. Okay? And that's it. If you want to simplify this even further, we could divide through by 2 to get a simplified version. So this is 6x squared plus 8x plus 1. That's a simplified version for 12x squared plus 16x plus 2. Okay, and that's it for those two questions. Hopefully you guys got that. Awesome. Let's move on now to the next question, guys. Okay, so I've got to move some stuff up here, guys. Now we're going to move on now to the multiplication and the division aspect of simplifying algebraic fractions, algebraic expressions. So here we go. So this is 2x to the minus 3 y squared multiplied by 5x y to the minus 3 multiplied by 4x squared y minus 1. So recommendation, take out the coefficients, put them in a bracket by themselves. So 2 multiplied by 5 multiplied by 4. We're going to segregate the x's away from the y's. So we have x to the minus 3. That's going to be multiplied by, there's no power here for this x. Well, there's no visible power, so it's just understood as a 1. And then we have this x squared here. So we have x to the minus 3, x to the 1, x to the squared, or x squared, and we're all multiplying. I'm going to merge that together now with the y. So this is y squared multiplied with y to the minus 3 multiplied with y to the minus 1. Okay, now everybody is organized accordingly. So 2 times 5 is 10, and 10 times 4 is 40. X to the minus 3 multiplied by x to the minus 1 multiplied by x squared suggests to us that we need to add all the powers. So this becomes x to the minus 3 plus 1 plus 2. Adding all the powers. That's the rule for multiplication of algebraic terms. Laws of indices number 1. Add the powers once the bases are the same and we're multiplying. And then we have the y here, so that's y2 plus minus 3 plus minus 1. So 40 is the coefficient of our answer, and then we're just going to be adding minus 3 to 1, which is going to be 2. Well, minus 3 plus 1 is negative 2. Okay, so this part here is negative 2. And negative 2 plus 2 is 0. Okay, and then finally now we have y. 2 plus minus 3 is negative 1. So this set of working out here is negative 1. And negative 1 plus another negative 1 gives us negative 2. Okay. Now you can leave the answer like this, or you could simply say the answer is just 4y to the minus 2. You must be wondering what happened to the x to the 0. Well, according to the law of indices, that states that any term raised to the power of 0 is equal to 1. So technically this would just be 4 times 1 times, let me just write this a bit better. Technically this would be 4 multiplied by x to the 0 is 1 multiplied by y to the minus 2, and then 4 times 1 is just simply going to be 4y to the minus 2. So that's why the x to the 0 disappeared. Okay, if you want to leave it with x to the 0, that's also fine, so you could do that. Okay. So hopefully you guys got that little working out, and it is advisable that you try to work out the problem in this particular order. It creates less confusion, and it makes it easier for you to calculate where you might get a little bit confused with the signs. Okay, so keep it very simple, guys. Let's get into the next question. So the next question here is going to be 9x to the minus 4 y to the minus 3 divided by 18x y to the minus 2. So now 9 divided by 18, let's just write that here in a bracket, and then we're going to segregate the x's from the y's. So that's x to the minus 4 divided by x to the, there's no power, so the understood power is 1. We're going to have to merge the answers together. All the letters are going to be in 1, so we're going to connect them with a multiplication sign, and that's y to the minus 3 divided by y to the minus 2. Now, a lot of my students made this error. 9 divided by 18 is 2. Okay? 9 divided by 18 is a half. So you can write a half, or you can write 0.5. We usually just don't use decimals when it comes to algebra. So we just simply keep it very and say 9 divided by 18 is a half. You can just go to the side here, 9 divided by 18, 9 into itself one time, 9 into 18, 2. So it's a half. Or as I said, you could use 0.5, totally fine. Then we're dividing now. Unlike the previous problem where we added the powers because we're multiplying, we are dividing now, so we subtract the powers. So this becomes x to the minus 4, and because we're dividing, we're going to be subtracting 1, subtracting whatever is over here. Y, the power here is minus 3. Because we're dividing, we're going to be subtracting whatever is over here. So we're dividing, we're subtracting whatever is over here. So this works out nicely to be a half x minus 4 minus 1. We add both numbers and keep the negative signs, so that's negative 5. This multiplication sign just means that we're going to merge the y together here. Minus 3, when two negatives clashes, we get a positive result. So minus 3 plus 2 is equal to 1. Minus 3 plus 2, that works out to be 1. Negative 1. So that's it. That's it for that question. So the answer is a half x to the minus 5, y to the minus 1. Alright, so hopefully you guys catch on to that. Of course, feel free to rewind this segment here and just have a closer look, slow it down a little bit, make sure that you're catching on as we go along. So hopefully you guys got that. Perfect. Let's move on to the next question. So now we're going to move on to the transposition segment of this paper, and we're just going to be rearranging a few formulas here. So we're going to be making P the subject of the formula. We're going to be making P the subject of this formula, and I had previously worked this question before, ladies and gentlemen, so I have to let you know that this here is an error. This P is actually not supposed to be here. Okay, we're gonna have some issues when it comes to working this problem if this P is here. So for my students who try to work this question and got into some errors, the error would have been on my part, on my hand. This would have been an error taken from the textbook to which this question was taken from. So my sincerest apologies for misleading you, but that extra P there is going to cause some serious issues when we're going to get our answer. But nevertheless, let's get into what if this was a situation presented to you. How would we have gotten to our answer? So let's start it off here. So we have K is equal to the square root of 1 minus 2p squared divided by 5. So the first thing that we want to do here, let's just make sure that this square root is all the way down. Okay, so the first thing we want to do here is to get rid of that square root that is in front of us right here. And the only way to get rid of that square root is to square both sides of the expression or the equation. So square both sides. Okay, so by squaring both sides, we're going to have K being squared, and that's going to be equal to the square root of what we're looking at right now, which is 1 minus 2p squared divided by 5. I'm going to give that a square. Okay, that's correct. So what that does for us now is that this power square cancels the square root. So this cancels this here. So we end up with K squared is equal to 1 minus 2p squared over 5. Okay, all right, so now that we have this K squared is equal to 1 minus 2p squared over 5, our next job here is to remove the 5 by multiplying both sides of the equation by 5. So we're going to have 5 multiplied by K squared is equal to 1 minus 2p squared over 5 multiplied by 5. We're using the opposite operation to remove the current operation. So since we're dividing our subject by 5, to remove the division we have to use multiplication. So this works out here to be 5k squared, and that's equal to 1 minus 2p squared, because this 5 cancels this 5. Now let's take the problem here to the top. So we have 5k squared. We have 5k squared is now equal to 1 minus 2p squared. We need to remove the 1. But before removing the 1, my advice is always try to check to see if your subject is positive or negative. Because when we're doing substitution, we always want to keep our subject positive. So in this case, if this was a plus, I would have you bring the 1 over or subtract 1 from both sides. But it's not 1 positive 1 in this case. Well, it's not positive 2p squared in this case, it's negative. So my recommendation here is to add 2p squared to both sides, or what we say is that we bring the negative 2p squared to the left hand side and bring the 5k squared to the right hand side. So this will come over here, or we just say add 2p squared to both sides, so 2p squared, and that's going to be equal to 1. And since we're now going to have to remove the 5k squared, it's positive, so we're going to subtract 5k squared from both sides, so that's minus 5k squared. Okay, now we have our subject positive, and of course we have it on the left hand side, which is the most preferred side of the equation. We're now going to have to divide both sides by 2. Okay, so we're going to have 2p squared divided by 2 is equal to 1 minus 5k squared divided by 2. Okay, so this 2 cancels this 2 here, and we're now left with p squared, which we are almost close to our subject, is 1 minus 5k squared over 2. And so with that said, now we are now going to just remove the square by raising both sides to a power of a half, or finding the square root of both sides. So square root of p squared is equal to 1 minus 5k squared over 2 square rooted. Okay, and so finally the answer that we're now going to have after we cancel here is that p is equal to the square root of 1 minus 5k squared over 2, and that's our final answer. Okay, beautiful. Hopefully you guys got that. Little long, little lengthy, but it is that lengthy simply because we're doing it step by step. There are a couple of lines that I could have skipped out, but I needed you to ensure that you understand every line of this problem. Okay, all right, perfect. So we're going to get into the final set of questions of this part of the video. Okay, we have now wrapped up the, okay, so we have another algebra question here, which is this transposition over here. Let's get into it. So now what we have here is, let's get some zoom up here for you guys. So we have 1 divided by r is equal to 1 divided by v minus 3 over t. So the first thing we want to do here is to get rid of the current denominators, which is r, v, and t. And we can do that simply by multiplying each of the variables in the expression, the equation, pardon me, by the LCM. So the LCM here is RVT. Okay, so the LCM here is equal to RVT. So we're not going to draw a line like we're trying to simplify. We're trying to solve or express V in terms of R and T. So we're going to say RVT multiplied by 1 over R is equal to RVT multiplied by 1 over V minus RVT multiplied by 3 over T. And what that will do for us now is that will allow us to do some cancellation. So we're going to have the R cancelling the R here. We're going to have the V cancelling the V here. We're going to have the T cancelling the T here. The T cancelling the T here. So we have automatically just removed the denominators in one line. So now what we have left is VT times 1 is VT, and that's going to be equal to RT times 1 is equal to RT, and that's going to be minus RV times 3 is going to be 3RV. Please be reminded that V is the intended subject here. So we have a V over here and we have a V to the right. So we need to group like terms. So now we're going to have VT positive. We're going to be adding 3RV to both sides, or as we say, bring to the left hand side and change the sign. So that's 3RV, because this goes over and becomes positive, or we add to both sides. And that's going to be equal to, let's write it a little bit better. So 3RV, and that's going to be equal to RT. I didn't need to move RT because my subject is not involved in RT. Now, I'm unable to add these terms because they are unlike. So what I'm going to have to do here is just to factor out or factorize my subject. Factorize for my subject. So now I have V as a common factor here. And so once I factor out V, T will be left. VT divided by V is equal to T. And 3RV divided by V gives me 3R. And that's going to be equal to RT. So since as T plus 3R is multiplying my subject, I'm going to have to remove whatever is multiplying my subject by division. So I'm going to have V T plus 3R divided by T plus 3R. That's going to be equal to RT divided by T plus 3R. I'm dividing both sides of the equation by whatever is multiplying my subject. That now allows me to cancel out whatever is multiplying my subject. And now what I'm left with here is V, which is the subject intended from day one, where they said express V. In terms of means that whatever you wanted to express in terms of should be in your answer. So V is going to be equal to RT divided by T plus 3R. Notice now that the subject I am looking for, which is V, it is not in my answer. What is in my answer is R and T, which is what they said here, expressed in terms of R and T. And you can see that R and T are in my answer. Alright? And that gives us the solution to that problem. Okay? Alright guys, so we are almost to the end of this part 2 of the video. Let's just wrap it up with the question 4, percentages and standard, the approximation, the direct proportion and percentages. Okay, let's go. So in this part of the problem now, we're looking at direct and indirect proportion. It says here in part A that it takes 14 men 10 days to build a bridge. Your job is to find out how long would it take 4 similar men to build the same bridge. So we're looking at an indirect or inverse proportion question here. And so there's a couple of ways in which you could do this. I teach my students one particular method, which I'm going to be doing first. Then I'm going to show you another method in which you can look at it. All right, so this is inverse variation here. So first thing you want to do is to write down what is it that you know first of all. And what you know is that 14 men, 14 men. And the job that is being done here is to build a bridge. All right, and this bridge, whatever this bridge is, can be done in 10 days using these 14 men. Your job is to find out how long would it actually take one man to do the job. So one man would obviously take a longer time, which is going to be 14 multiplied by 10. So one man logically would take 140 days to do the job. Your job is to find out how long would it take. All right? How long would it take 4 men to do this job? Okay, so literally it would take, so one man can do it in 140 days. So 4 men would take 140 divided by 4, which would obviously be, let me see here, that's 140 divided by 4, so that's 25 plus 8, that's about 33. So 140, oops, pardon me, 140 divided by 4, that's 35, pardon me, not 33, but 35. So it would take 35 days for 4 men to do the job. And that makes logical sense. Okay, 14 men would take 10 days, less men will take more time. Okay, and that is just one way of doing the problem. I always write down what is it that you know, and then proceed to find out how long it would take one portion to complete the job. And then from there, you can literally figure out whether you need to divide or multiply to find the answer you're searching for. If it's inverse variation, you divide. If it's direct variation, you're going to usually multiply. All right, so that's just one way of doing it. Let's have a look at the other method. The other method here is to write down the inverse variation formula, which is y is equal to k divided by x. All right, and k here is known as your constant of variation. So we know that y varies directly as x. Y is going to represent the amount of men, and x is going to represent the amount of days. So 14 men will take k divided by the number of days. So k divided by the number of days. So y, the amount of men, right, will determine the amount of days take to do this job. So the first thing that we need to do is to find the constant of variation, which in this case here is that k is going to be equal to 14 multiplied by 10. And k is going to be equal to 140. So now going back to the formula again, that y is equal to k over x. This time you're trying to find out how long. Let's check it. You already know that 4 men will do you want to know how long, which is x, because x will represent the number of days. And y will represent the amount of men. So you want to know how long it would take 4 men to do the similar job. So this time 4 is going to be equal to y, because y represents the amount of men. K is 140. And x is going to remain as x, because x is now representing how long it would take 4 men to do the same job. Alright, and this method is a method that I didn't teach my students this method, but it does exist. So you can utilize this method by using a formula. So if we multiply both sides by x, we're going to have 4x is equal to 140 over x multiplied by x. This x cancels this x, so we have 4x is equal to 140. And so if we divide both sides by 4, x is going to be equal to 140 divided by 4. X will be equal to 35. So we get the same answer by using a different method. The method I showed you before this was just writing down what you know and finding one portion. This is just using a formula for inverse variation or inverse proportion. Okay, awesome sauce. Let's get into part 2 of this question. Now part B says here that if a car can travel 250 miles on 15 gallons of gas, how far will it travel on, part of it is cut off here guys, it's actually supposed to be on, it just looks like or, but it's on 30 gallons of gas. And do not round off, give an exact value. Okay, all right, so once again we can use the method of writing what you know. So 250 miles can be completed by using 15 gallons of gas. How far will it travel on 30 gallons of gas? So you can, let's write it the other way. 15 gals would take us a distance of 250 miles. How far would 1 gal carry us? So 1 gal can take us 250 divided by 15. So 250 divided by 15, that will take us a total distance of 16.66 recurring. So that will take us 16.66 miles if we had 1 gallon of gas. Our job now is to find out how far would 30 gals take us. So if 1 gal can take us 16.66 recurring, then 30 gals will take us 30 multiplied by 16.66 recurring. Let's just turn this into 16.67. And that's going to take us approximately 500 miles. And it just kind of makes sense, because 15 gallons will take us a distance of 250. If you double the gallon, you double the distance. So this question here is just kind of very straightforward. The method is what you need to learn, because not all the time you'll have a perfect ratio of 1 to 2 here. Okay, you're not always going to have that ratio. It could be a lot more complicated, so you need to use this method here that we are showing you. Always write down what you know here and proceed to finding out what you want. And as I mentioned to you before, if it is indirect inverse variation, then you would have to divide. But if it's direct or direct proportional or direct variation, you multiply. That's just one method. Okay, so that's pretty good for you. Let's look at the formula method. The formula for direct variation is y is equal to kx. Okay, again, k is the constant of variation, and y represents the amount of miles, because the amount, well, okay, so the amount of miles is dependent upon the amount of gallons of gas that you have. So y represents the miles and x represents the gallons. So in the first instance, 250 miles can be done within 15 gallons of gas. Okay, so x is 15 here. So the constant of variation here is 250 divided by 15. So this 15 cancels this 15 here. So this is 16.66. That's equal to k. So the constant of variation here. And the constant of variation means one portion, one part. What is one portion? So therefore, using the formula y is equal to kx, we are now looking for y. We want to know how far it travels on 30 gallons of gas. So that's equal to 16.66, which is the k, multiplied by the new gas that we have now is 30. And that will definitely work out to be equal to 500 miles. Okay, so both methods work for you there. Awesome. Alright, so hopefully you guys got that part here. And we're now at the final portion of this paper. I think this is going to be a 4 series paper, because I don't want the video to be too long. So I just want you to get a portion and move right along. Okay, now next here is going to be 4 is what percent of 12. That is just simply going to be 4 divided by 12. It's almost like saying you get 4 questions right out of 12. What percentage did you get? And clearly you will see that that's going to be 33%. Okay, you can just go on the calculator and verify. 4 divided by 12 multiplied by 100, and that's 33.33%, which rounded off is approximately 33%. Alright, and next question here, part B, you are to find 2/3% of 1200. So 2/3%, remember that percentage is out of 100. So 2/3, you've got to also divide it by 100, and you've got to multiply now by 1200. The mistake that a lot of students make is that they say 2/3 multiplied by 1200, and they completely forgot that 2/3 is a fraction. is a percentage represented as a fraction, and remember that percentage is out of 100, so you still have to divide by 100. All right, what you can do though, you can say 2/3 multiplied by 1200, and then you're going to divide the result that you get by 100 once again. So let's do it both ways. So 2/3 divided by 100 times 1200. What we're looking at here is that the 3 is a denominator and the 100 is a denominator. So we're looking at saying here that's 2 divided by 3 times 100. We just make common denominators and multiply them. So that's 2 divided by 300, or 2 divided by 3 times 100 multiplied by 1200. Okay, so 3 times 100 is 300, so 2 divided by 300 multiplied by 1200. 300 into itself 1 time, and 300 into 1200 goes 4 times, so 2 times 4 is 8. Alright, so that is 2/3% of 1200 is 8. 8, let's see, if this is dollars, they didn't say whether it's dollars, it's just 8. They just said 1200, so the result is just 8. Okay, alright, so that's just one way of looking at that problem. Let's look at it another way. We could say that this is 2/3 multiplied by 1200. Okay, so let's say you do forget to divide it initially by, let's say that you do forget to divide it initially by 100. So that's 2 over 3 times 1200. 3 into this into itself 1 time. 3 into 1200 goes 400. So 2 times 400 is equal to 800. But then remember that it's a percentage, so you've got to divide it again by 100. And if you divide this by 100, the result is still going to be 8 over 1, which is equal to 8. Okay, so you get it both ways. You've just got to remember these little subtle things, such as remembering that a percentage is out of 100. So regardless of however your percentage is given, whether it's in fraction, mixed fraction, or decimal, you have to always divide the result by 100 or divide the percentage by 100. Alright, so hopefully you guys got that part. And just to wrap up this section here, we are to round off 0.086724 to 3 significant figure. We know that significant figures are going to be figures literally that are greater than 0, provided that 0 is after a non-zero digit, or 0 is in between 2 non-zero digits, then the 0 will be considered to be significant. In this case, these zeros are insignificant to the number, meaning that removing them will not change the value of the number. Hence, our first significant figure here is 8. Our second significant figure here, let's get some zoom up here for you guys. So our first significant number here is 8. Second significant figure is 6. And the third, the second significant figure is 6, and the third is 7. So we draw a vertical line here, because they said they wanted the 3 significant figure. And we check the digit that comes after, which in this case is 2, and it is less than 5. So we just remove all these digits, ignore the 2 and the 4, and our final answer here is 0.0867. Now there are 5 digits in the result, but there are only 3 digits here that are significant to the value of the number. Alright? Okay, awesome. And then the next one now is 2 decimal places. Decimal places are going to be digits that immediately comes after the decimal point. So hence, regardless of whether or not it is a 0 or a number greater than 0, it still holds a place after the point. So my first decimal place here is 5, and my second decimal place here is 0. Once again, I'll draw my vertical line right after the second. In this case, it's second. Check the digit that comes after. It is less than 5 once again. So I just ignore the 2, the 9, and the 5, and my result here becomes 0.50. Okay? Alright, and that is for significant figures. There are going to be videos on my channel. Do search is that you are unfamiliar with the concept of approximation to decimal places and significant figures. There's a full video on my channel that explains exactly how we go about working problems like those. And finally, this last question here, the distance of the sun, let's just move it up here. The distance of the sun to the earth is 93 billion miles. Express this number in standard form. So we're gonna have to write out what is 93 billion. So that's 93, 1, 2, 3, 1, 2, 3, 1, 1, 2, 3. So first 3 zeros 93,000, next 3 zeros 93 million, last 3 zeros 93 billion miles from the earth. That's where the sun is, that's the distance. So now to put this in standard form, we've just got to try to move the small point, which is all the way out here in between the 9 and the 3. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the point is now in between the 9 and the 3, so the result is going to be 9.3. Standard form is always times 10. Now we moved our point to the left, okay, to the left, so it makes it positive, so positive 10. Okay, so it's 9.3 times 10 to the 10. That is the distance of the sun to the earth written in standard form. Again, there are videos on my channel as it relates to standard form, so you can check those out and see if it is that you can get up to speed when it comes to doing standard form questions. There are examples and there are theories. Okay, so with that said, that brings us to part 2 of this segment where we went through some algebra, some percentages, direct proportion, indirect proportion, and some approximation. Do check out part 3 of this video series of this end of term exam paper that was created, and hopefully it is of some benefit to you. All right, please smash the subscribe button, like and share if this is of benefit to you, and do take care until next time. We're signing out. Bye bye.